So the concept we are going to discuss is curve fitting by the method of least squares. So curve fitting is used to find the best fit line or the curve for a series of data points which passes through maximum number of points, and curve fitting produces an equation that can be used to find points anywhere along the curve. The method implemented to find curve of best fit is least square method. So when we do real-time experiments, we get a series of data, say x1, y1, x2, y2, x3, y3. So if you see figure 1, when we plot the points, the figure 1 gives the scattered data, which is random one. In figure 2, the curve passes through each and every points, but it is very difficult to find the interpolation polynomial. So using curve fitting, we find a curve, precisely a polynomial, which passes through maximum number of points, and also using this interpolation polynomial we can find the value of unknown values using the known value. So the method we are going to implement is least square technique to find the best fit line or curve. So now in curve fitting there are three cases. First one is fitting a straight line of the form y equals ax plus b, where a and b are parameters to be determined. So now for the given data we have to find the equation of a straight line which passes through maximum number of points, which is a curve of the best fit. So now, so the main aim is here we have to find the constants a and b. So we have to write the normal equations to find the values of a and b. The main thing is to write the normal equations. So the normal equations for a straight line are, so now here the first term in the right hand side is a into x. So the power of x, here the power of x is 1. So what we have to do is first multiply x on both sides. So x into y equals a into x into x is x square plus b into x. So after multiplying x on both sides, take sigma on both sides. So equation becomes sigma xy equals a into sigma x square plus b into sigma x. So now the second term contains only the constant b, but here the power of x is 0. So the power of x is 0. So write down the equation as it is. Write down the straight line as it is. So y equals a into x plus b. Now take sigma sign. So sigma xy equals a into sigma x plus, so here sigma b I from 1 to n. I from 1 to n means, so the total value is given. So sigma b I from 1 to n, we can write b plus b plus b up to n times. So this is nothing but n into b. So instead of writing sigma b I from 1 to n, we can write n into b. So these two equations are called the normal equations for a straight line. So if the straight line is y equals a plus bx, so here also the same thing. So first term it is a constant, power of x is 0. So write down the equation as it is. So normal equations are, so write down the first equation as it is, y equals a plus b into x. So now write sigma on both sides. sigma y equals sigma a I from 1 to n. It becomes n into a plus b into sigma x. So sigma a I from 1 to n, it is n into a. So now second normal equation. So second term contains bx, power of x is 1. So multiply x on both sides. So equation becomes x into y equals a into x plus b into x square. Now take sigma on both sides. Sigma xy equals a into sigma x plus b into sigma x square. So this is for a straight line. Now second case is fitting a parabola or second degree polynomial. So now we have to fit a parabola or second degree polynomial for the given data, which is the curve of best fit. So parabola will be in the form of y equals ax square plus bx plus c. So here also we have to apply the same procedure. So here, in order to find the parameters a, b and c, we have to write the normal equations. So where a, b and c are parameters to be determined. So now normal equations are, so now first term, so in the first term power of x is 2, so multiply x square on both sides, then take sigma. So x square y in the left hand side, right hand side a into x square is x power 4 plus b into x square into x is x cube plus c into x square. So take sigma on both sides. So sigma x square y equals a into sigma x power 4 plus b into sigma x cube plus c into sigma x square. Now in the second term power of x is 1, so multiply x on both sides. So x into y, a into x square is x cube plus b into x is x square plus c into x. So now take sigma on both sides. So sigma xy equals a into sigma x cube plus b into sigma x square plus c into sigma x. So now third normal equation we have to write. So in the third term power of x is 0, that is x power 0 is 1. So write down the equation as it is. So y equals a into x square plus b into x plus c. Now take sigma on both sides. So sigma y equals a into sigma x square plus b into sigma x plus, so here sigma c I from 1 to n, that is total number of values, we can write n into c. So sigma c I from 1 to n, we can write n into c, it is plus nc. So for a parabola or for a second degree polynomial we get 3 normal equations, but for a straight line y equals ax plus b, which is a linear equation, we get 2 normal equations. So now if the equation of a parabola is a plus bx square bx plus cx square, so now normal equations are So first term, it is a constant. Write down the equation as it is. So y equals a plus b into x plus c into x square. Take sigma on both sides. Sigma y, then sigma a I from 1 to n. It is na plus b into sigma x plus c into sigma x square. So now second term, power of x is 1. So multiply x on both sides. So x into y equals a into x plus b into x into x is x square plus c into x cube. So now take sigma on both sides. Sigma xy equals a into sigma x plus b into sigma x square plus c into sigma x cube. So now we have to write the third normal equation. So you have to see the third term, power of x is 2. So multiply x square on both sides, then take sigma. So x square y equals a into x square plus b into x square into x is x cube plus c into x square is x power 4. So now take sigma on both sides. So sigma x square y equals a into sigma x square plus b into sigma x cube plus c into sigma x power 4. So now to find the constants a, b and c, it is very important to write the normal equations correctly. Now here the third case is fitting a curve of the form y equals a into e power bx, which is an exponential function. So now consider the curve y equals a into e power bx, where a and b are the parameters to be determined. So now to solve this exponential function, we have to take log to the base e on both sides. So taking log to the base e, on both sides. So equation becomes, so log y equals log a plus bx into log e. So here by default the base is e, but we know that log e to the base e is 1. So equation becomes log y equals log a plus bx into 1. So now, so log y, take it as capital Y. For log a, take capital A plus b into x, where capital Y is log y to the base e and capital A is log a to the base e. So now the exponential function is converted into the form of a straight line by taking logarithm on both sides. So now once it is converted into the straight line form, we know how to write the normal equations. So now write down normal equations for the straight line. So normal equations are, so here the first term is a, which is a constant, power of x is 0. So write down the equation as it is, don't multiply anything. So y equals capital A plus b into x. Now take sigma on both sides. So sigma capital Y equals sigma a I from 1 to n, which is nothing but n into a plus b into sigma x. So now second term, in the second term power of x is 1. So multiply x on both sides. So then take sigma. So equation becomes x into capital Y equals a into x plus b into x square. X into x is x square. So now take sigma on both sides. Sigma x into y equals a into sigma x plus b into sigma x square. So here, so once writing the normal equation, we have to solve these two equations to find a and b. So solving these two equations, we find capital A and small b. But what is capital A? Capital A is log A to the base e. So this gives small a. Small a is e power a.